Hi everyone, welcome back to Peter's Academy. Thanks for joining us today. Today we'll consider a question in chemistry and actually in chemistry practical. And today is a question on clove oil. And what do you mean by clove oil? Clove oil, according to this question, is an essential oil with a wide number of uses. Now, clove oil is a raw material used industrially for producing perfumes, and it can be used also in producing painkiller or pain reliever for toothache. So it has a variety of uses in what? In industry. Like clove oil can also be used as a flavoring in foods. So it has a lot of uses industrially. So we are trying to produce what clove oil here, and the clove oil can be extracted from a dry clove bud by distillation. Clove oil can be extracted. Clove oil can be extracted from a dry clove bud, as shown in the picture. You see the clove bud on the screen now by the process called steam distillation, as as follows. Like now, the clove oil here is being extracted by steam distillation in the laboratory, and the apparatus is given below. So I'm going to actually explain the apparatus first. Then I'm going to analyze the situation to answer the following question. Just follow me because this is a practical question I'm actually doing theoretically. So now the first thing is to actually look at the apparatus used in this experiment. The first one is the steam generator. We have steam generator as number one apparatus to consider. This steam generator. So and this one is what is the number two, which is the glass tubing or a tubing that is carrying the steam from steam generator. We have the adapter here that allow the passage, the one-way adapter that allow a passage of the tubing and also serve as a stopper. Now, I will omit this four. I will omit this number four because I'm going to use it to explain these functions. Now, this number five and this number six here. Now, coming back to number four that I omit. Now, you can see this apparatus here. It has three mounts. We call it three mount adapter. It is three mount because it actually helps us to connect to the stopper, which and then connect to also the RAM button flags and also connect to the library condenser. So it is three mount adapter. That's why it's called three mount adapter. So this number five, as is known as the chemistry practical, this is a RAN button flags. So which is connected to cleansing, and this cleansing, the third mount of this cleansing apparatus or adapter is connected to what we call library condenser. Condenser is just help you to what? It helps you to maintain the level of water that is being used, the amount of water that is being used in heating up the cloves here. So now the condenser, what condenser does is just that it cools down the experiment. It cools down the experiment, and this condenser, which is number six, has the water inlet. This is the water inlet that is connected to. This is the water inlet, and this is the water outlet. So this is where the water comes in, and this is where it is connected. It's going to be connected to the hose. It's going to be in between this. There's going to be hose put inside this place and connected to the tap, and this one is taking the water back to the to the sink. So now we have the number seven here, which is the apparatus that we need to consider is the vacuum mode adapter. Please note that vacuum adapter. In most cases, we don't use this just to vacuum adapter. So this is connected to vacuum just to remove air, something if there's any vacuum or air inside the vacuum. So they call it vacuum adapter, but in most cases it's not necessary. So and the last one here is G, where we collect our products. So the popular conical flask. This conical flask. So we have the steam generator number one, we have the tubings, we have the stopper, one-way adapter, we have the cleansing, number four, number five, we have the RAM button flask, which our material is, and number six, we have the library condenser, the vacuum adapter number seven, and number eight is the conical flask, where we have our distillate. Now let's talk about the materials. I have to talk about the apparatus now. Material. Now looking at the material here, we have the starting material. We have the starting material, which is clove. The starting material, which is clove, number one. We have the clove, which is usually a brown in color, which is usually brown in color. Clove is brown in color. And then we have number two here, the water. I want you to see here. This is water here, H2O. Water, H2O. Some minimal amount of water was added. So we have the clove. This is number two. So are the two starting material that we use in the experiment. So we have the brown clove seed, and then we have the water inside the more water. Then when the experiment started, there was a steam being generated into this place. Now this steam is passed through, which actually helped this to boil quickly. So this boil are the words they were applied. So this one boils at 100. Water begin to boil at 100. Don't forget the boiling point of water is 100 degrees Celsius, and the boiling point of clove itself is 250 degrees Celsius. Now that's why steam distillation is very, very important here. In order to reduce the normal temperature of getting clove oil out of cloves, we actually put water inside the water experiment, so as to ensure that we actually get our product, which is this distillate here, at the boiling temperature of water. So that's the essence of this steam distillation, so that the clove oil can be cut in at a very low temperature of at 100 degrees Celsius, which is the boiling point of water. So meaning that as the water is boiling at 100 degrees Celsius, the clove oil is coming with it. This clove oil is coming with it when the water is boiling at 100 degrees Celsius, and that's the essence of steam distillation. It helps us to get our products at lower temperature. So now, using this basic information to answer the following question, what are the things that we need to know in this experiment? So we have already know that. Then the question says, number here now, I'm talking about the question, answering the question now. So A said that distillate product consists of clove oil, and then it contains another substance A. Now this is the distillate. We are told that it contains clove oil. Of course, it contains clove oil. That's our target. And it also contains another substance A. What is that substance A? The substance A would be water that is from the steam. So this distillate has clove oil and water. It has clove oil and water. So that's what we are getting from this distillate. So this distillate is actually made up of clove and water from steam. Don't forget that the water here is from the steam. As we are boiling the word experiment, as we are introducing the word experiment, as well as the experiment is going now, the clove is being boiled inside water, and from here there will be what? There will be steam. There will be evaporation. This is vapor. We call this one vapor. The vapor here that is coming here and call it steam or vapor. It's actually in form of water, but along with that water comes with clove. So that's why you can call it water in form of steams or vapor. So that's it. So water from steam or vapor. So that's our A. A is water from what? Steams. A is water from steam or vapor. Now, state the appearance of the distillate. We have to state the appearance of the distillate. What does the distillate look like? Now, when we have something like clove and water together, what will the distillate look like? Because the distillate itself is made of clove oil and water itself. So what would be the appearance of the distillate? It will look like a milky or cloudy appearance. Milky or cloudy appearance. Please know that it have milky or cloudy appearance, or cloudy. You can even write cloudy. And this cloudy appearance can be tagged emotions. Emotion. This can also be called what? Emotions. Emotion. It forms emotion because it is cloudy. We call it emotion. EMULSION. Emotion. So it has a cloudy or milky appearance, which look like an emotion. So that's the appearance of the distillate. A cloudy or milky appearance. So which look like emotion. I will show you the picture on the screen as well. So these are the two things these are the appearance the way you can describe the appearance of the experiment or the product obtained from the distillate. Don't forget, when you steam the clove in water, you get your product at 100 degrees Celsius, and then the appearance look like a milky or cloudy solution, which is called emulsions. So state one advantage of extracting what? We have to state the advantage of extracting clove or using steam distillation. As I told you earlier, the purpose of the steam distillation is to what? The main purpose of steam distillation here. The main purpose of steam distillation is to collect our product clove oil at lower temperature. So the main purpose is to get the product at lower temperature of about 100 degrees Celsius. To get our product from at lower temperature at about 100 degrees Celsius without decomposing the clove oil itself. Because if you expose the clove into a temperature of 250 degrees Celsius, there is tendency that we are going to lose the clove oil in decomposition. So in order to get a clean product, we boil the substance in the presence of water, which is called steam distillation, and then we get a good product. So what this steam distillation helps us to do is that it helps us to obtain a clean product at lower temperature without requiring more energy. So it means that it also saves energy. It saves energy for the reaction because you require little heat to actually carry out. So your product is obtained at low temperature. It saves energy as well. And also, you can also say it's a good method as you obtain a good product, a pure product. Like you don't actually necessarily have to decompose the substance for you to get the product. So now that's that about the parts. Now the next thing is to move to the B aspect now. Let's go talk about the B aspect. Now, the B aspect of this experiment. Let's the B aspect of the experiment. Now, when I talk about the B aspect of the experiment, they said Eugenol may be extracted from the distillate by liquid extraction. Now, the first thing is we've actually extract the clove oil by steam distillation from the cloves. Now we have our distillate now. Now we have our distillates in the conical flask. Let me just try and now from here, what we now have now is like these are our distillates here. So we have our distillate. Let's say we have our distillate now. These are our distillates. Now, and in this distillate lies our eugenol. Eugenol is inside this distillate now. So we have to extract. Now, the eugenol can be extracted from the distillate by liquid extraction using the solvent cyclohexane. So in this distillate is the compound called eugenol. It's a compound, and the method of obtaining this compound eugenol is by liquid extraction, LL extraction. So now liquid extraction, we can obtain our eugenol by liquid extraction. So now, when I say describe with the aid of diagram, question says describe with the aid of diagram. So the aid of label diagram is suitable procedure for extraction and collection of eugenol from distillate. How do we actually collect this eugenol from distillate? So what we do is that you transfer this. The first thing is transfer into separating phoneme, SF. That's the first thing you need to do. Transfer into separating phoneme with the aid of diagram. Don't forget, you clamp. You clamp and then you put your separating funnel. This is your separating funnel. Then we put your distillate. Then you add. So you add. The next thing is to add your cyclohexane. Add cyclohexane. Add cyclohexane. Now this cyclohexane here will come in different portions. We have different portions of cyclohexane because we're going to extract this more than twice. And that's more like we have at least twice and minimum of 2 extraction, and you can go as much as the third extraction as well to get your what the maximum value of clove oil in your what in your distillate. So you add 10 milliliter of cyclohexane. 10 milliliter of cyclohexane is being added into this. You add the transfer. You add 10 milliliter of cyclohexane. So we have the process of washing here now. What do you mean by process of washing? The first thing is to transfer the water into SF. Then you add your cyclohexane using 10 milliliter of cyclohexane. Then you carry out the process washing. The washing is just the process by which you vent. You vent your apparatus. So like I haven't added what a distillate, your distillate inside the separating funnel, you close it up, you add your cyclohexane, and then you vent. The process of venting is what we call you move it to and fro, and then in the process you are actually extracting your oil from the what? From the emulsion. So and this process is called washing. So what you are going to get is that you're going to get two separable layers, two separable layers. So the three things that you allow this to rest after venting. You know, when you are venting as well, venting is the process by which you wash, you vent the what the apparat, the SF to and fro, and then you release the pressure. There's when you release the pressure, you turn it down, and then you release the pressure from the bottom, and then you close it back. Then after that, you clamp it back, which is very, very important. This one is very, very important. So you clamp it back. You clamp it back again. Now, and allow it what? To rest for some minutes. You clamp and then allow the solution to rest, like keep it for a while. Allow the solution to rest. Are you to rest? So you allow the solution to rest a little bit. So this help the solution to separate into two layers. And then here you're going to have two layers. The two layers in such a way that you are going to have your aqueous layer below, and then you're going to have your just this one to the organic layer. So we have the organic layer and the aqueous layer below, the aqueous layer. Aqueous. So you have the organic layer and the aqueous layer. Organic layer is where we have the cyclohexane plus our clove oil. We have the cyclohexane and our clove oil. And the aqueous also we still have our clove oil, a little bit of alcohol, but our water. So here we have the aqueous here is having what? Water plus remaining oil. The remaining oil that we have. So this one is having cyclohexane and remaining oil. So that's why you have to do your second extraction again, so that you get all the oil from the aqueous solution. So you do it repeatedly, like twice or thrice, to get maximum value of your clove oil from the extraction. So that's how to do it. So after that, the first thing is, remember, you transfer it to what? To the SF. Then you add 10% of cyclohexane. You vent, which is the process of what? Washing. Releasing the pressure from the what? From the SF as you carry out the process, and ensuring that you close the tap each case you are releasing the pressure, and they allow the solution to separate out. It is separate out, and then you can now collect your clove oil by removing the aqueous layer first. When you remove the aqueous layer first, then you pull back the aqueous layer that you remove first. Yeah, you are going to tag through this. In this case, you are going to have two separate conical flags. So let me write it there. The separate conical flags will be the conical flags A and B. So you have flags A and then you have flags B. One for organic layer and the other one for aqueous. So this one will be for aqueous. So you have two conical flags. So and then this B, which is the aqueous, will be poured back for second extraction. And then you have your what? Your second extract. Then you have the first and the second extract. You get the first and second extract, you had them together. Then what do the next? Then you carry out rotary evaporation. No, you carry out washing. The next thing is induction. Number 4. You have washing. So after you've extracted, after extraction, so I tell you, extraction is just a process of washing, and then you collect all of your organic in one place. So we have your organic in one place. You have organic in one place, which I want to represent with yellow. So you have your organic layer now. So the organic layer, you have the organic layer now, which is made up of cyclohexane. Don't forget, it's made up of cyclohexane plus your clove oil. That will represent as cyclohexane and clove oil. So these are your organic layer, but you haven't finished the experiment because you need oil. You need the clove oil alone. So the next thing is to do the drying first. You do the drying. Drying process is by using magnesium sulfate. You drying by adding what? Magnesium sulfate. So what do that? You add a portion of magnesium sulfate inside the what? You add magnesium sulfate inside this. Add magnesium sulfate inside this. So and then you carry out if you had magnesium sulfate inside the organic layer, what it does is that it removes the remaining aqueous part. It removes the water part from it. There's any aqueous that is still left in the organic layer. What it does is that by the magnesium sulfate, which is the anhydrous magnesium sulfate, it forms a clump inside the solutions and then therefore remove the aqueous. So now, after you've added what magnesium sulfate and you've wired what in the conical fat so that the magnesium sulfate can absorb the remaining aqueous solution, you carry out a gravitational filtration. Gravitational filtration. We call it gravitational filtration because it involves this of gravity. I think you know what we mean by gravitational filtration. So it means something like you have your filter paper form and then you just have to have it gravitational filtration. So we have gravitational filtration. Now, filter paper inside, put your filter paper. So filter paper. So you put filter paper and then this is what we call gravity filtration. So for the gravity filtration, GF. Am I writing? Gravity filtration. So we have gravity filtration here. You put your solution, you bring it now. For gravity filtration. So that's step 6. After that, after you've removed that, then you carry out, which is step 5. Well, 5, let me just let's go down a little bit. Step 5 is step 6 is what do you do again is that you collect this in after you've collected this, now you now have your pure organic. This is your pure organic. You still have this is your pure organic layer. Pure organic layer. I call it pure organic layer because let's call it pure organic layer because it does not have any form of what aqueous part anymore. Pure organic layer. And then what you do now is to remove the cyclohexane. Don't forget that this is made up of cyclohexane. Cyclohexane is just 6,6. Cyclohexane has 6,6H12. Yeah, 6,6H12. Cyclohexane has 6,6H12. Separate 6 liters and plus oil. So we still have your cyclohexane and oil here. But we need to get only oil. You only need oil. Aim of this experiment is to get our clove oil. And to get this our clove oil, the last thing you're going to do is to actually carry out what? Heating on water baths, or you carry out rotary evaporator. Heating in water baths. Heating in hot water baths. Or you remove the cyclohexane using rotary evaporator. So this is the last step you can carry out to actually carry out. So you see that the two, you can heat water bath, and to heat on water bath, it means that you're going to have your trough, your small trough. You are going to have your small trough, something like this. You are going to have your beaker. Then you have your source of heat, whether it is Bunsen burner or you have hot plate, whichever you are using. You must have your source of heat. So the source of heat is like this. I will just put source of heat. Then we bring your conical flask with your organic. And as you supply heat here, what is left here is the organic let me separate it out now. What leave here as your heat, this is heat here. And as expose this to heat, your cyclohexane, which is H6, C6H12, boils at 81 degrees Celsius. So as soon as it gets to 81 degrees Celsius, this cyclohexane will evaporate. So when cyclohexane evaporates at 81 degrees Celsius, what you are going to have left will be your oil. It will be kind to be oil. So cyclohexane will boil at 81 degrees Celsius. Even if we use rotary evaporator, it will leave at 81 degrees Celsius. So now, and then what we're going to have left is oil. And that's about the collection of oil from cyclohexane. So why you use cyclohexane is that it is easily removed by heating at 81 degrees Celsius. You don't need much heat to remove cyclohexane. And number 2 is that it actually dissolves clove oil. That's why it forms 2 layers when we are washing it with cyclohexane, because the clove oil can actually dissolve in cyclohexane. So as it dissolves, we have 2 layers. So we have the aqueous layer and the organic layers, and then we separate them out into conical flask A and clinical B, whereby we actually we give A towards organic layer and B towards aqueous layer. We wash the aqueous layer again to obtain another second extraction. Then we had all the extracted portion collected. We remove all the aqueous that's actually left in the extract, which is organic layer, by adding magnesium sulfate. And then after that, we'll carry out gravity filtration. After gravity filtration, we carry out heating on water bath or use a evaporator depending on the laboratory you are working in. So these are the experiments. Then there are going to be a pictorial representation for them. So these are the ways you actually carry out the experiments. So because it is just theory I'm having here, in the future I'm going to do the practical test. So now we have stage 2 precaution of cyclohexane that make it a solvent. Stage 2 properties. Stage 2 properties. That's stage 2 properties of cyclohexane that makes it a solvent suitable to use in this experiment, that is in this liquid extraction. Why is it suitable to use in extraction of Eugenol? I've told you what makes cyclohexane unique here, which is C6H12. C6H. What makes it unique is that number 1, it dissolves oil. It dissolves the clove oil. So Cyclohexane is an organic solvent which dissolves the chlove oil easily and make the layer, the extraction, to divide it into layer, organic layer, and then the aqueous layer. So it's an organic solvent that dissolves chlove oil, number one. And number two, it's immiscible with the aqueous solvent, which is water. So it has an insoluble properties, which has an insoluble properties in water, that is an aqueous solution, and then it can dissolve chlove oil. These are the two things that make it unique. Number one, cyclohexane can dissolve chlove oil and is insoluble in aqueous solution because an organic solvent. And number two, it can also be removed under less energy. You don't need much energy to remove cyclohexane, as we've done the last step in heating water, but it boils at 81 degrees Celsius, so it is easily volatile. It can be, in fact, if you leave cyclohexane in the laboratory, in the laboratory under the full wood, it will evaporate with time. But because it is toxic to the environment and the amount that we are using might be too much to be left for volatilization, so we prefer to remove it on water bath. So it's volatile, but it can be removed even in at room temperature. So there are the two things that make cyclohexane very unique. So there's that. Now number three is which is the aspect of this. They said state one precautions that could be taken during the liquid extraction to maximize the yield of Eugenol. What are the precautions? Number one, make sure your extraction is more than once. In fact, the advisable number of extraction should be 3. Carry more than one extraction to maximize your Eugenol yield. So use first portion of cyclohexane, use another second portion of cyclohexane. If needed, use third portion of cyclohexane, and then make sure that the cyclohexane you're using is no more than 10 ml, depending on the quantity of clove you are starting with and the quantity of clove you are expecting at the end of the reaction. So ensure that you use minimum volume of cyclohexane and you extract more than once. So that's just it. So that's one of the precautions. And another precaution that you must also carry at the liquid extraction is that you must also ensure that every stage when you're drying with magnesium sulfate, ensure that every substance is being carried into the water. Ensure that you scrape everything out. Ensure that the magnesium sulfate is well filtered out of the water experiment. So those are the precautions that you need to note and careful of. The heat, the most important thing is the extraction. It's very, very important in the extraction. It's very important getting maximum heat of Eugenol. So describe how Eugenol can be isolated from dry heating cyclohexane mixture. I've already done that, which is the process of what we'll get here is pure organic layer that I call it. It's called dry cyclohexane Eugenol. We have Eugenol. No, Eugenol here is the word oil that I use is Eugenol because the oil contains about 75% of Eugenol. So that's why they call it Eugenol. So there's also other component of compound inside that, but Eugenol takes the larger percentage. That's why we call it Eugenol here. So as I said, pure organic layer contains of Eugenol and cyclohexane. And to isolate it, we use heating on water bath or radio evaporator. I've explained it. You can also rewind and get it back. So that's that about that. So let's move to the third aspect, which is very, very important. I think I've already made this for, but then we moved it down. So I'll just have to clean some of this place. So now we have the third aspect. I think you can easily use this one, and this is the remaining part of the question. Just box it where I can see it. So the first part is suggest one use of Eugenol. Eugenol is a compound. Is a major component in the oil that you obtain. The clove oil is a major component in the clove oil. Eugenol is a major component in the clove oil, and it is used in manufacturer of many industrial products, such as number one, it is used as aromatherapy, like it is used in perfume industry. That's what aromatherapy is used in perfume industry. It is used to produce good scent. So it is one of the raw materials, starting material for producing perfume. So because Eugenol has some sweet aroma, you can perceive the odor of Eugenol as sweet whenever you are producing it. So it has a sweet smell, and then maybe because of the presence of, I think alcohol doesn't have, or alcohol doesn't have good smell anyway. So it has OH in it. It also has ether in it. So maybe that's the reason why it has good odor. There are a lot of factors to that because it has an heater on it here. Definitely, ether is very, very important in having good odor. So draw the structure, and then that's why you're going to. So one of the uses is that it can be used as one of the starting material in making perfumes. Number two, it is used in the production of pain relief or painkillers. So it is used as a pain relief or pain killer for toothache. It is used locally. I think in India they use it to cure toothache locally, and also some other part of country. Although it has not been proven in the laboratory, but it's used and people are using it locally. It's very, very sweet, curing toothache. And then the last one I think is it can also be used in flavorings. That's very, very important. You can use in production of flavorings for foods. If you want to have what good, flavors in your food. Eugenol is very healthy, but a minimum amount is required because you don't want to have it in much amount. Each can be toxic to the body. So it's used in minimum amount of flavoring of foods and then so on and so forth. So it's also used in antibiotics. Antibiotics are drugs that can help you to fight diseases and germs in the body. So it's used in the production of what? Antibiotics. It's used in medicinal chemistry as well. So, and then we are asked what? We've talked about this one. So now this one, draw the structure of eugenol. As I told you, eugenol, structure of eugenol looks like this. Inch of space, structure of eugenol. Eugenol has a benzene ring. Has a benzene ring. That is, it has a benzene ring, and then it has a major functional group of OH. Or a major functional group of OH. And then to its side is what? Meta. Which is the meta. To its side, to the side. This is, you can call this one the auto, the meta. Okay, we can call it to the meta. All this, the auto, the meta, and the para. So to the auto side, we have the OCH3. This I'm saying, the ethyl group that I'm saying. So, and this is methoxy. This is the OH group. It is the OH hydroxy group. This is the methoxy group. And then in its para, it has H to CH double bond CH3. It has a propane here. It has a propane. So it's supposed to be 2. It has a propane here. You can see it has a propane. So it has a unique structure. So this is in the auto position and this is in the what? In the para position. You have to be careful of that. So you have to be careful. So this is the actual structure of it. So let's see whether it's completed. This is CH2. This one has 2 bond, and this one has CH. It's connected to C. I want to make sure that it's 2 bond. Yeah, it's completed. The propane is also completed. So this is the structure of the propanol actually. So, and then what are the spectroscopic technique? This number 2. This one is done as well. This one is, let's talk about the spectroscopy now. Technique. Now I talk about spectroscopy. Now spectroscopy is just a method of confirming the structure of what? Of eugenol. Spectroscopy method as a method that we use to confirm the structure of eugenol, that okay, this is eugenol. So what are the spectroscopy method that we use? Name a spectroscopy method. Number 1 is we can use infrared spectroscopy. Infrared spectroscopy is actually used to identify individual functional group like OH hydroxy group. It shows whether there's hydroxy group. It shows whether we have a meta group. It shows whether we have a propane group that is double bond. If there's a presence of double bond, if there's a presence of OC. So what it does is that it helps you to identify the region where we have OH, identify the region where we have OC, and the region where we have carbon-carbon double bond. That's what the IR does for us. Very, very important. Another one is mass spectroscopy, MS. This one helps you to identify the molecular mass. The molecular mass. When you calculate this, do we have the molecular mass? MZ. This one measures the time of MZ. So that's what it does. Do we have that kind of molecular mass when we carry out the what? When we analyze the compound under MS, mass spectrometry? Then the next one is that you can also use NMR. NMR can we have HNMR. It depends on the level of purity that you need. The level of what? Confirmation that you need. You have HNMR, and then we have CNMR. We have different type. We have this one is for proton NMR, and this one is number of carbon. This one is for number of proton. That's number of hydrogen. This one is number of carbon. Do we have the same number of hydrogen and number of carbon in the compound that we are analyzing? That is, do you have this number? You can count this. How many carbon do we have? How many hydrogen do we have? So this one NMR help you to get the exact number of hydrogen, the exact number of carbon in the compound of we analyzed. So these are the spectroscopy method. Any of these that you mentioned, you are going to get your answer. And also maybe wanted to check the concentration, the absorbance level. I use UV is very rare to use. And UV and maybe HPLC. This is actually helping you to actually calculate the concentration. So majorly is for concentration. So HPLC, they might not be necessarily used. So, but these three will help you to identify the identity of eugenol in the sample. These are the major ones. So this one is just concentration, but it's not necessarily what needed. But any of the three we do 1, 2, 3 we do for you. So now, but it's better to use the combination of the three to be on the safer side. So the last one is the studies. Calculation aspect. The calculation aspect. So what are we calculating? Calculate the volume of the dry eugenol. Density. This is the density of the eugenol obtained in 18 grams of cloves. That's the mass of starting material. Starting material is 18 grams. And the heat is 7%. So the density of eugenol, which is I will call it, use this symbol for it, density. And this eugenol is 1.06 gram per centimeter cube. So the first thing is to actually get the percentage. This is the percentage heat. But get the percentage of eugenol first. So the percentage of eugenol is 77%, but you have to get the actual mass of eugenol by using the percentage yield. This is the percentage yield here. You have to get the actual yield of eugenol. So to get actual yield of eugenol, ME is equal to the percentage yield now percentage yield multiplied by the starting material MS. Please follow. ME, the mass of Eugenol, equal to percentage yield multiplied by the what? Mass of what? The starting material S, so which is the clove itself. So now the mass of Eugenol now is going to be 7/100 times, because 7% times 18 gram, whatever you get will be your what? Mass of Eugenol. So I'm going to calculate on a 7 divided by 100. So divided by 100. So what do we have? We have 1.26 gram mass of Eugenol. That's the mass of Eugenol you obtain. But we are asked to calculate the volume of Eugenol from the density. Density is mass over volume. So to get your volume, it's going to be volume equal to mass over density, right? Yeah, by making the volume formula. So we have volume equal to mass. What's your mass? 1.26. What's your density? It has been given in the question, which is about 1.06. Density of Eugenol is 1.06. So definitely your volume of Eugenol, now dry Eugenol, will be what? 1.26 divided by 1.06. Why do we have to measure the volume? Because Eugenol is in a form of liquid. So it needs to be a liquid, a colored liquid. So it's an oil, you know how oil looks like, right? So we have 1.1886 approximately towards 1.2 ml. So that's that milliliter whole centimeter, because they start with centimeter, so I will prefer leave it like 1.2 centimeter cube. ml as centimeter by the same thing. So that's that about the experiment. So thanks for watching.